evening, everyone. My name is Yuan Ji. I'm a kind of independent consultant work remotely from home. I'm in the US. Here, my daily job is in a big Java program. I'm passionate programming, especially the M language. Today I will introduce Parse, very powerful tool for parsing. And by the way, I'll talk about this in JavaScript. And we don't have this. We can come with it. We don't have this kind of thing. So as I mentioned, my daily job is to maintain a two-big system. So story. One day I was assigned a ticket. It's about a QA report. He said there's validation error. I submit this form. I click the box. I look at the system. There's one page to submit the form. And it's about 20,000. Huge form. And I go around and with the user. What to do? Fortunately, I can access the QA environment. So I went to the QA, open the systems, play around, and find out, okay, I can refuse that. And this error only happens when I select the service provider. So what's wrong with this Spanish doctor? So I have to play around later. Then I found out I can introduce my local environment. So I create the doctor Spanish input or Spanish value. Then finally I figure out what is wrong. The problem is not about Spanish doctor. The problem is about Spanish phone number. Why? So as soon as I find out where the error is, easy to see the code. I look at the code. That's a validation code. The code has a comment. Comment say, do not use this validator when we start supporting the application. Interesting. So I don't know what to do. So I ask what to do. Architect said, oh, UI doesn't support just code. So you be wondering why? Phone number. Phone number is too hard. Tell you why. Let's look at the current UI for American phone number. Like this. We have area code. Now we have phone number. 7 digits. And we have 7. That's the slide for the American. Now the company tries to open market for the market. So everyone can input phone number, not only the American phone number, but the UI chain. All these small pieces of stuff. So only one line input text for international. So what is the problem? Do you have a question? Exactly. The problem is when we let the user freely input their phone number, all kinds of things. Whenever they want, because phone number you write down always has all kinds of formats. Let people easy to understand and remember, but let computer hard. So that's the problem. You will say, oh, we have record expression. Right? We have record expression. Okay, that's the record expression to validate American phone number. And go pick out for any company, or any countries, or for Spain. Because Spain phone number not American. American phone number is about 10 digits. Spanish phone number only have 9 digits. That's why we got this error. But with this, today I have good news. Today I will introduce a wonderful combinator for Parse. So this is not my first time talking about AM, so I did many talks about AM introduction, about topics. So today I will just go directly to the AM Parse API. I have assumption that you can read that AM code. If you feel difficulties intimidated by those APIs, so different from JavaScript, it's okay. Doesn't matter, yeah. So just follow me, go along. So I'll show you how AM handles difficult parsing problems. Look at the API. What we have is just parsing. You look at the parser, you think about the value. Everything in AM so when we have a parser, whatever parser, we can parse A, smaller than A, any type, whatever any type. So how to use that? We have a function called one. This is the signature of the function. We give a parser for any type A, we give the text string type. And the one function will return a result. The result will be just the result type. Result type is found and result is able to handle errors like script exception. Found exception. Use result to handle exceptional cases. Result can carry error or value. So it can be okay, means sounds good, and it gives you a value of the parsing result. Or we have error, and okay, something wrong, maybe have error type, or whatever you define type of error. And the error here in the parser one function is a list of dead ends. Dead end means I try to parse this text of the screen and I found some problem. I cannot continue. We have list of dead ends. We have several issues of text. So the dead end we have the row and column. So there is a problem I have. Issue and some problem. You can go to this guide website to find out. But basically, one function is simple. In your parser, you can see the result. Okay, how can we use that? I will show you. Let's talk about some very, very simple, extremely simple functions. Beautiful. One pass a flow, symbol, keyword, or whatever. So those kind of building blocks provided by the parser package that we already provided. So here are some examples. Int is a parser to parse integer. So we run this int parser with a string of 1. I got okay 1. Integer result, the value is 1. If I pass in 1.34, that's a float. That's not integer. I got error. That's some error message or whatever. Problems. That's a problem. Of the float, same. So float can handle integer. Also. Pass 1 to 3 for float after okay 1 to 3. Is 1 to 1 5. Last row after integer and so we now try to add some symbol. Symbol is just text. So if we have a square bracket, I have the square bracket, I use a single square bracket, the result will be okay, and it's called unit value. You understand? If I have some different things to say, I want to have a symbol about the square bracket that has 4 elements. I'm expecting symbol really. So last way usually show you how to use parse. You just call one function. Everything is function. Okay, let's have a so here.
Let me make it a little bigger.
Okay. Okay. So this is the alley to have the online demo. Code run it dynamically. The code is very simple UI. So we have in Elm, usually we have some model. You need to define a model or you solve kind of solve truth. Now we have update function, we have view function, now we have main function. Main function is kind of a start point to define passing runtime all the init function, view function, update function. So that's something interesting is I have very simple UI. That's the input. And the input is a button, submit button. Now I have some two options to give you what's the user input and what's the parser result. So the code is also very simple. You have the input is the text. Now when the user input type in, dynamically capture the user's input, our display, our file change. After the change message, then you will display the user input dynamically. So that's how ARM works. That's called ARM architecture. Okay, so not important. The important thing is when I click the submit, button, it will call update. Submit handling is try to parse using the parser run and parser in parser to pass the content. The content is what the user needs. So if I click the submit button, parser result. So based on the result, it's okay, and I just display. So if I have something not a number, you mean okay, the result is I expecting the integer, but not. Column is 2, row is 1. The first row and the column 2. Now it's not integer. So if I have 3, 8, here, we just try to grab the first integer from the text. Found it. Okay, that's okay. Successful. All following characters. You can use parser as following characters. So last way, how we parse integer. Very, very simple. Already provided by the parser library. Let's talk about something more advanced. Because passing integer is so trivial, so easy. Why we do that? Because this kind of doing well. And we will have more powerful functions in the parser package. So that is to let you parse more complicated text. So I will introduce several other functions. First one called succeed. Succeed function is very interesting. So that means always succeed. Whatever you give it, always give your parser. It's kind of interesting. Never fail. The thing about it is kind of like doing nothing. Why we're doing that, I will show you later. Because it's like in the mathematics about zero. So in the mathematics, we do the plus, we do the substitution or addition. Zero is like nothing. You add zero to anything, you get the same thing as the result. So zero seems like useless, but actually zero is so powerful. Without zero, you cannot do any mathematics. So it's like this: the succeed function seems like it is nothing, but actually it's very powerful. Then we have this pipeline. This is called heap. This is like an operator. It's like a type. We give a two parser and keep this parser. Okay, we'll talk about it.
So if you were to just say, like in kind of plain English, what that's doing, it's like a function that takes in two functions, or it's taking in two values.
Yeah, it's actually parser always a value, but this parser value can carry a function. So the first parameter of parser, the parser one, it's a function parser A to B. And the second value is parser, but it's parser of A, type of A. So when we combine together, I got parser of B. Because from parser A, it's kind of input of this function. Then I got B. So it's kind of combination. We combine these two together, I got parser B. So think about this way. It's like a maybe when I show example, you understand. Right now, it's so too abstract. We have those function combination, and we pass that as a pipeline. This type we pass parser A to that parser A to B. I got parser B. That pipeline. It's like hiding. But here, this one is what you know. It's another interesting parser. He passed another, also two parser. Parser A for hip, parser B for ignore. And we ignore the second one. We only keep the first one. So this is usually called ignore. So we will see how we use that in example. Another kind of function is called and then, but I won't show the example of and then. It is more advanced, but also very, very powerful when you try to do level of the function. Okay. The example is more interesting. So for example, I have x to represent a point. What is point? Point usually is having for x and y, value, and they use the parentheses, point, and use the comma to separate x and y. So that's the text I want to pass. So how can we do that? So first, I define the type of point. Type of point will have x and y. Those are type. Then I have a parser function of value parser point. This is a parser to parse point. So how can I define point parser? I use those pipeline functions and some building blocks. Combine to build parser for point. So let's say we can read that as the way we try to parse a point combine. First of all, let's say I will look at a symbol, that parentheses. So if I look at the point of bracket 1, comma 2, I first look at the first parenthesis. Okay, I know that's right. That's a point of string. Sorry, that's a text representation of point. So, but I ignore that. But I don't need that. I need to recognize. So I use the ignore function. See, I want to read a symbol. When I read that, I throw away. Then I look at the spaces. The spaces just pass any empty space. So I look at the spaces. So it may be one or more. Doesn't matter. I look at if there's a zero or more spaces, I throw it away. Then I look at it. It should be a value of a float number, and I use the keep function. If I keep the float, actually I pass that to the point. We will see later. So then I keep going. I may have spaces, zero or more spaces. Doesn't matter. Then I may have a comma. Still have a comma. That's the way. Then we have spaces. Then I should have x. I keep that. I pass to the point. Remember that way. This is kind of function of this function back to the previous numbers. So then space throw away another back and throw away. So by that, when I run point parser with a text about 1 and 2 of point. So that way we combine a lot of small parsers together to get a bigger parser. We can parse a more complicated text. Now, so the tricky part is how we understand this. It's very tricky. We try to use the flow parser. So this is kind of if we ignore this one, doesn't matter. So we think about point and flow, how we put all together. And this one flow and another flow. So look at here. The first parameter is a parser, and this part actually succeed parser. Succeed point. Actually, succeed always return a parser of A. Always return a parser of point. Actually, it's a parser of point. This first parameter is a parser of point. And remember, I mentioned the first term of point is a type. It's also a function. The point function has two parameters, x and y, both and both. When you pass point with two float numbers, you get a value of point. So here, when we use the keep pipeline function as float and float, we pass the float value to the point construct the function as equal. Now that's called point. That's how we combine all these functions together. Now we get the value of what we want.
So, in the definition,
Yeah.
how do those
Yeah. So
Could you repeat the question?
the question is, I have two keep functions with the float. How can I map that to a point x and y? That's a good question. But what I try to explain with this keep pipeline functions. This is very tricky part. So you have to remember, in functional programming, everything is kind of like a function. And function composition is try to pass those function and function along, because they are all higher order functions. The function becomes input, and also the return of a succeed parser. The parser of A point also function. So this tricky part point order.
So could you just explain, like, I think I'm getting confused because on the left, where you have like the pipe kind of equals and the pipe not. So parser, those are types. What is the parameter and like what is the return value?
Okay.
Like where does the kind of body of the function start?
I think it works we try to expand out more. On the left side, those are the type signatures. Those are the definition of function type. So, for example, succeed is a function. I only display the signature of the function. We have input of first parameter. Only have one of any type A. We will return a parser of A. To succeed is a function very special. You pass succeed anything. You will return a parser for that thing. So here we have succeed point. Point is a type. The type we care about. We pass point to succeed. We get what? Get a parser point. Understand that? Okay. So last kind of trivial, but remember that point is type. Point is also a constructor function. Because point, when you give point to those values, you will get a value of point. Okay? If you pass 1 and 2 to point, you will get a point of x to 1, y to 2. So last way, we get a parser point, this A, and we carry on. Remember, for the ignore outline, we ignore that, so get rid of that, doesn't matter. More interesting is the keep outline function. We pass two parameters. Parser of something, parser of other thing. We got parser of third thing. So what's the first parser? Something. It's parser point. Remember, that's a parser point. And the second something is a parser float. What's here? We have float. And we pass that to that function. We get what? We get point like A to B with A or B. So that's another trick. That's called partial application or query. That's interesting because we said point is a function has two functions x and y. If we only pass float, one float, what we get? We get another function with partial application or query. But point is two parameters. If you only have pass one, you will get another function with another kind of point x with the parameter y. So the last way how we do the query in the Elm, now we have that is, think about it, this is like a point A and B, like point x and y, then you will get you should get a point value B. But actually, because of querying, you have like a point x, you should get point x and y. Then you get from here is this is a point x, or just say another function or another parser for point x, but they're missing y. Then you go on with the second flow, you pass that again to the parser of point x. Then you have the parser flow, you get parser of point. Because you pass that two flow, you get the two flow value, you pass to the point. That's the two parameters. So then the two parameters of the point get enough data, you get a parser of the real point.
So
and you have the point.
So the type of like symbol and spaces and float and spaces there, those are all parsers? Like that's how you can pass them into the functions?
They are all parsers. Like symbol is like a building block we talk about. To get symbol. Space are kind of space is like a pass any space characters or empty. that case, if you have a space or no space, doesn't matter. Just ignore this. So for the ignore, you see we have two parsers. Parser keep, parser ignore. We always ignore this whatever we get. So even we pass like parentheses, we pass comma, we pass space, and we ignore that. We don't care. But we only care for root value. So we carry on. And we keep that, we also pass to the point function. And the point function will have enough input parameters and result point value. That's how it works. It may take some time if you are not familiar with function programming. It takes some time to twist your brain to understand how it works. But when you have this aha moment, you understand like a value, what's the value means, what's the constructor function means, what's all those function composition means, what's all the higher order function means, carry the function along, and we apply the function, and we use a query actually apply this function. And everything will work, and works beautifully. This code is very easy to read and understand.
It's also been nested, right? With values where the first Python symbol
Okay.
is with the argument that's going into that Python. You have two arguments, one which is the first parser, the other which is actually
the question is, can we do the nested parsing for the point? The answer is, for this parser, no. Well, this parser only handles one level about the point structure. You see, from the flow, you just read the flow. You look at this is a left parenthesis, find that, throw away. Find the space, throw away. Find the flow value, you keep that as the point. Find the space, throw away. Find the comma, throw away. Space, throw away. Find flow, pass to the point. Find state, throw away. Find right parenthesis, throw away. So we don't do the nested point value. That makes sense for nested.
I think what Ben is saying is taking a single value of passing to
Yeah.
the familiar way to think about that is the other way is to see it as a reducer and sort of
Yeah. Okay. Sorry, I misunderstood the session. Okay.
It's like
So,
the functions take two arguments.
Yeah.
You look at the two line, it looks like one.
Right. It looks exactly like a reactive JS. You have pipeline. It's like a pipeline. So you have that. So that's the way usually the format of our function actually we tend to like to like this. Because it's like the first parameter is always here. Then all the last parameter is coming from the left side. Coming. So we just like the bunch of the text, it's like a big text. It goes through the pipeline. So the first one, the symbol, you will eat the left parameter, throw away. Oh, space, keep that, throw away. Oh, this is the flow, keep that. And go on, I keep another flow. And go on, finish. Now I put this two flow pass to the point. So it's all pipeline. So I tend to understand this code like a pipeline. So it's much easier for me to follow pipeline slowly. So, but you can understand as like a functional nested function. And if you think about nested function, you will think about the multi-level. This is kind of very powerful to get that. Pipeline understand is much easier to get this. Okay, so the other question. The next one, I have a piece of code. So the piece of code is pretty much exactly like what I did for the concept. But here I have a point. I have a type of point, and I have a parse of point. Exactly, I show you examples. So here is code, and everything else pretty much the same. We still have the input and submit button. For the logic, the parse is different. So right now, when I call the parser one, I'm not using the int parser, I'm using the point parser. And I pass the content of our user input. So if it's okay, I'll display point. Otherwise, the error. So let's see how I do that. So I say 1, 2. User input is 1, 2. I can submit point. That's how it works. So if I have a different, like 1, A, not. Oh, I expect in the flow to do something different. In the first row, in the column 4, 1, 2, 3, 4, it's A. So I expect in here, it's a float value. Like give me an A, that's wrong. So here we can see with M parser, very easy to find out what is wrong. Think about if I'm using regular expression. Just give you, okay, that works. Now with what's the problem? Okay, that's the example. This is also an example. M parser package. It's very, very easy. Okay, let's go on. Voices, we also talk about national phone number. Actually, I try to pass the international phone number. Okay, now to pass a more complicated thing, that is a little bit more function or nice. Now, if you look at the string, sometimes it's like a point, sometimes maybe phone number, or sometimes different. So, on one string, for example, I want to pass something, but the string can represent different things. So, I want to have the ability to pick and select what kind of value I expect. So that's how we have two functions, very, very useful here. One of I give a list of parsers. Okay, here's a list of parsers, and you try to pick out, to look at the string, tell me what's the result. So, for example, a list of parsers may have integer or string or symbol all together. Then, using one of, we will try to use all those parsers to iterate, to try to find out which one match with the text. So, for example, we have like the JSON literal. JSON literal can be different things. It can be number. It also can be a boolean or it's just a null. Think about the three situations. So I give you a JSON literal. It can be just literal true or false. I mean the boolean. It can be 1, 2, 3, 4. It's the number. Or it can be a null. I mean just null. So how can I pass that kind of thing? Or other time?
No, we're 5 minutes left.
Okay. So maybe I cannot finish my international phone number. So let's just try this one. This one also very interesting. Is I want to pass JSON literal. So I use for one of, and I also use for map. Because in map, think about function programming. You use map everywhere. Anyone with like Python or some other script libraries, we use map a lot. But here, we use map everywhere. So we have a list of parsers for float. I want to pass float. I want to pass as true keyword or false keyword or null keyword. Right? That's all parsers. parsing result by JSON. Your JSON can be number, boolean, null. This kind of data. So how can I do that? I use map. To map the parsing result to the type I want. So I have one of this array or list of it's a list of the parser and use map to map the result to what I expected. So in this way, we use one of and map. We combine a list of parser, we get what we want. So this parser can pass any JSON available. Whether you pass it, you give it as a 1, 2, 3, 4, or true or false or null, you give the correct value of it. So one of and map also very powerful function in your parser. Cover. So lots of times we want to pass just string. And sometimes the string is not a structure, like phone number. We don't care about structure. We just give a number. So we have choppers. Chopper is like the animal to eat the character one by one. So we have 3 functions, very powerful functions, also very interesting. Chop if grab one character, and I use the function to see if that character meets my predicate. If it's true, right. Not error. Top while is I keep grab the character, and I use that function predicate to see if that meets my predicate. If it's true, I keep going, keep grab. If it's false, I stop. And get chop string is whatever I have this parser use the chop, I will get the string back. So the example is also very interesting. So any PHP programmer understands the PHP variable has a special format. You always start with the $sign, then either it's underscore or some letter. Then carry several underscore or alphanumeric letters or characters. So last way, how we format PHP variable. So how can we parse a PHP variable name? Now we use chop. So first of all, we have a function called succeed. We remember the succeed always have a parser of whatever we pass it. The succeed will have a parser of unit. And chop here, so we just go through the pipeline. We look at chop here, say the first character must be $sign. If not, I stop with an error. Bye-bye. If yes, pass that, then I got parser of unit. Right? Then I ignore. Because it's ignore. I ignore that. I go chop here. Second character must be underscore or a letter. So I got that. I ignore. Then I keep chopping, keep eating the character. All the following must be alphanumeric with a digit, letter, or underscore. I keep starting from the bottom. When I finish, I pass that to get chop string of the 50 as a value. So that's the way how we combine those functions together to get a parser to parse 50 variable names. Very powerful, but also very straightforward. Real code, just like our mind. Very straightforward. So next several pages are all about parsing. So I don't have time to finish. So I have a demo. So the demo is for international phone number, I always have a $sign with a country code of 1 for America, North America, Indian or US. Then I have like a phone number. You can have like this, that, and we got country code. The phone number is country code, that's one number. So whatever you have different format, doesn't matter. Always can keep one. That's how we do that. Very powerful. I will skip the code because it will take maybe another 30 minutes to explain the phone number passing. Very interesting. Anyway, I give credit to this. First of all, is this presentation by demystified Parse and L from last year's conference, and most of international phone number passing code coming from this blog, or introduction to the Parse package. So if you are interested, you can search and find out this blog to read how we pass international phone number. Most of my phone number examples come from that. Okay, so today I introduced the parser and I give